Hello everyone, in this video we're going to be adding binary. So we're going to start off with some super simple examples, so I'm going to jump right in. If we have 0 and we want to add another number to it, we're going to choose 0 for this example, we're going to get 0. Okay, and if we have 1 and we want to add 0 to 1, we're just going to have 1. I think this is pretty straightforward and everyone can understand this. Where it becomes a little bit more complex is when we go beyond 1. So for example, if we have 1 and we want to add another 1, so in traditional maths we would know that this is equivalent to 2, but in binary we can't do that because 2 doesn't actually exist as a number. So 2 in binary actually is represented by 1, 0. So how do we get there? So if we take an example, in traditional maths, if we have a number like 5 and we want to add another 5 to it, so we all know if we want to add these two numbers together, it's equivalent to 10. But how do we exactly get to 10? We know when we put 5 and 5 together that we carry 1 to the next column. We can cross these out and we know we carry 1 to the next place. Then we just put down 1, then this column's total is 0. So we write down 10. So in a similar way, that's how our binary numbers work. So we've got 1 plus 1, which is 2. We can't represent 2, so we carry it to the next place. And the answer is represented as a 1, because this one here, we bring it down, and now these two 1s here have been moved forward to the next column, so these are also equal to 0. So 2 in binary is represented as 1, 0. Now, what if we want to add more than 2? What if we had like 3 or 5? How exactly does that work? So if we have 1 and we want to add another 1, and we want to add another 1, so this would be equivalent to 3 in decimal. So if we jump into a decimal example first, it might make a little bit more sense. So instead of having 5 and 5, let's say we have 5 and 5 and 5, and we want to add these three up together. Now we all know that this equals 15, but what exactly is happening? So again, we know when we reach 10 we have to carry it on to the next column. Okay, so it's 10 in our decimal format that we're used to dealing with, while in binary it's 2. So that's where we get base 10 versus base 2. We know that 5 and 5 is 10, so we can cross them out and we can carry 1 to the next column. And then if we bring this 1 down and we see what's left here, 5's left. So similar to this example, we have 3 1s. So we know that we can't represent 2 in binary, so we definitely can't represent 3. So what we can do is we can get rid of these 2 1s and we can carry them, and we have this 1 left over here. So we're going to bring these 2 down. So we'll bring this 1 down and we'll bring this 1 down. This 1 1 is the equivalent of 3 in binary. So let's jump into a better example. Let's assume we have the number 1 0 1 0 and we want to add the number 1 0 0 1. Now if you remember from the previous video, you might remember that this 10 10 is equal to 10 and that this 1 0 0 1 is equal to 9. But if you know that or you don't know it, it doesn't matter. You should still be able to find the total of these two binary numbers without knowing their decimal form. We'll put down our first number 1 0 1 0 the same way that we'd do in traditional maths, and we put whatever number we want to add to it underneath it. Again, this is something that we're very familiar with traditional maths. We're going to add these numbers together. So if we have 0 and 1, what's 0 and 1? It's 1. What's 1 and 0? Again, it's 1. 0 and 0 is 0, and 1 and 1, okay, so that's 2. So what we could do is we could look back up here, what we done when our answer was 2. So we carried 1 to the next column and it was left with 0. So this number here is the exact same one, just goes down here. So we're going to just jump into another example just to make sure that this is clear. So we're going to have our example as 1 0 0 1 1 0, and the number we want to add to it will be 1 1 0 1 0 1. So again, we're going to add these numbers together. 1 and 0 is 1, 0 and 1 1, 1 and 1, okay, so that's 2. So we can't write down 2, so we need to carry it. So we're going to just put a little 1 here so we know we're carrying it, and we can just cross these out. We don't have to use them. So we put a 0 here. Now we look at this, so this is 0 plus 1. That leaves us with 1. Then here we have 1 plus 0, again this is 1, and 1 and 1, and we know 1 and 1 is equal to 2, and we know 2 in binary is equal to 1, 0. So if we want to make sure that our answer is correct, we can double check it by creating a little 2 to the power of grid. So I'm going to go through that quickly. You would have seen this in previous videos. So if we count our 1s and 0s here, we can see there's 1, 2, 3, 4, 5, 6, 7. There's 7 1s and 0s, so we'll have to go up to 2 to the power of 6. That gives us 7 different places. So if we run through this, 2 to the power of 0, 1, 2, 4, 8, 16, 32, and 64. So what we can do now is we can write down our binary number that we have, which is 1, 0, 1, 1, 0, 1, 1. Now, to make sure that we're correct, it's always good to convert our binary numbers into decimal, and then we can add our decimal numbers to make sure that we're correct. So we're looking for the answer at the moment. So we can see if we get 64 and multiply it by 1, and then we get 16 multiplied by 1, 8 multiplied by 1, 2 multiplied by 1, and 1 multiplied by 1. That will give us our answer. So if you go and multiply these all together, you get this, and then if you add all these numbers together, you get the answer as 91. So what we can do now is, we know that this binary number here is equal to 91. So the next thing we need to do is we need to get these other two binary numbers, and we need to convert them into decimal, and then we can add these two numbers together when we've got the decimal format, and we can check to make sure that it's 91. So now we've got our binary number here, and we can see that it's equal to 32 plus 16 plus 4 plus 1. If we add all these up together, we can see that it's equivalent to 53. So we can put 53 over here to make sure that we don't forget about it. So if we get the numbers 53 and we add 53 with our other number, which is 38, and we get our total will be 91. And this is one way we can make sure that our binary number that we've solved is actually correct. So this is the final example that we're going to go through. This one's going to be a little bit more difficult. So our number is going to be 1, 0, 1, 1, 0, 1, and our number that we want to add to it will be 1, 1, 1, 1, 0, 1. So the last time we added our binary numbers together, and then we converted them into decimal, and then we added the decimals to make sure that we were correct. We could also do it the other way around. So before we go and add these together and get a result, we could convert these two binary numbers here to decimal. We're going to do it this way this time. We bring these binary numbers over here into our little grid, so it's easier for us to figure out what the equivalent is in decimal. So for this first binary number here, you can see it's equal to 32 plus 8 plus 4 plus 1, which comes to a total of 45. Then we can do the exact same thing with this other binary number. Our second binary number is equivalent to 32 plus 16 plus 8 plus 4 plus 1, and this total is 61. So if we have 45 as our first binary number and 61 as our second binary number, we take our number 45 and 61, it gives us a total of 106. So what we can do now is we can get our 106 number, and we can convert that into a binary number to find out what number we should see here. So what we can do is we can take our number, which is 106, we can take away the biggest number we've got, so that would be 64, so minus 64, and that leaves us with 42. So we can put a 1 here. Then we need to see, can we take our next biggest number from 42? So our next biggest number is 32, and we can take it from 42. So if we have 32 minus 42, will leave us with 10. So we'll also put a 1 here beside the 32. Our number is now 10, so we can't take 10 away from the next biggest number because our next biggest number is 16. So we have to put a 0 in there. Now we look at our next biggest number, which is 8. So we can take 8 away from 10, which will leave us with 2. So we can put a 1 in this 8's column. So we're left with 2. So can we take 4 away from 2? We can't, because it would leave us with a negative number. So we're going to put a 0 in there. We look to our next column, which is 2. So we can actually take 2 away from 2. It would leave us with 0, but we can do it. So we're going to put a 1 there. And once you've reached 0 here, you can fill in all the rest of the columns with 0, or you can do it out. So you could bring down 0 to the next line, and you could check to see, can you take it away from the next number, which is 1. Again, you can't take anything away from 0 without leaving you with a negative number. So we're just going to fill in 0 for this. So this number here, 11011010, should be our answer. So let's go and do it out. So 1 and 1 we know is 2. So we're going to put a 0 down here. We're going to carry our 1 along here. And we're going to put down 1 here, because 0 plus 1 is 1. Again, 1 and 1 is 2. We're going to put down a 0. We're going to carry this 1. Now we've got 1 plus 1 plus 1. This is now equal to 3. So we could get rid of 2 of those. We could carry it, so we carry it on to the next column. But we still have 1 here, so we need to put down our 1. Now we have 1 and 1. 1 and 1 is 2. Again, we're going to put down our 0. We're going to carry our 1. Now we've got 3 different 1s we have to add up. So we know 3 1s is equivalent to this. So 1, 1. So if we compare this 1, 1, 0, 1, 0, 1, 0 to this number here, they should be exactly the same.